Hey folks, thought I'd put together a quick Loom/presentation about MCP and understanding the different methods and transports, as well as looking at the history of MCP as it relates to HTTP APIs. So let's just hang out and take some time and learn about MCP with some fun analogies and generated images. So let's first take a start and think about MCP. Is it HTTP APIs this whole time? Well, kind of. Generally, most MCP servers and clients that we've seen so far are wrappers around HTTP APIs. That doesn't need to be the case. They can be file system APIs, anything, but from our NLX worldview, we've been working a lot with HTTP APIs in the MCP world. So let's see how that makes sense after we do a quick background of the history of MCP. About 2014 in November, the protocol was announced by Anthropic as a system to connect AI assistants to data systems. Open sourced in December 2024, VS Code, the extension Continue was the first one that actually took advantage of MCP in the desktop land. Then between January and February, there's this MCP explosion that happened where Azure, AWS, Cloudflare, other hosting providers are quickly rolling out MCP servers for their data stores and other cloud functions. And then the client list expands. We've got JetBrains and IntelliJ, Claude Desktop, and other open source solutions are start to be out. Then in March, OpenAPI officially supports the MCP protocol. This is a big endorsement to the industry, basically rallies around this and says MCP is the way to enhance AI agents with tools. You start to get a little bit more of industry alignment around May of this year in 2025, where Google announces the agent-to-agent toolkit. And that now allows you to connect agents to different agents where each of those agents leverages MCP for their own tooling. And then today we're starting to get a little bit more maturity around use cases and getting to layer on top multiple protocols for interacting with MCP that makes sense based on the way folks are consuming this. So let's take a peek at our agenda. We're going to look at the MCP restaurant. We're going to look at MCP transports, and we're going to look at MCP clients. So let's talk about the MCP restaurant. So this is a fun analogy that I think helps break down the differences between HTTP APIs, MCP, and agent-to-agent frameworks and protocols. So let's order up some clarification from the MCP restaurant. So HTTP APIs, it's the HTTP API menu. You are given a Swagger document, some sort of menu to follow. You read everything. It's up to you to make the request to the kitchen directly based on what you see. Any changes or something that you make after you order, you're going to have to make a whole nother order. The kitchen will tell you yes or no, your order works or not, but they're not going to do any sort of advice. They're not going to guide you through selecting the right thing or making any decisions on that menu. It's up to you to understand the menu and to make that request. So this is old-fashioned HTTP. You've got a document, you make the request. Now we can wrap this with an MCP to start interacting with our AI assistants. So in this case, MCP is kind of like a waiter. The waiter knows the menu inside and out. The waiter knows the API spec inside and out. They do need to know what information from you to make the dish that you would like, but they know exactly what the kitchen needs to know to prep it. They know that you need to say spice level. They know that you need to say rice, brown rice, or white rice. So they'll do all the talking with you before making your order in order to make that correct. So if we think back to the HTTP menu, it's up to you to understand the different types of rice, what they're there for, make that order, know the spice levels. In MCP world, the waiter knows this. So this is the agent. Claude Desktop is the waiter in this case. So for MCP, Claude will converse with you to make sure that it gets all of the required parameters to make that MCP request before actually making the request. So that's what you'll see when you use Claude Desktop is it'll ask back and forth some questions before it actually invokes that tool. It's making sure it understands everything. Then layered on top is the A to A maitre d'. So if we look at this, A to A is agent to agent. These are agents talking to agents. So in this case, you could imagine ordering from a maitre d' that knows your preferences very well, that they coordinate everything without you having to ask. So this is you basically saying, I want dinner, not having to answer questions about rice, spice level, anything else. Any conversations between the waiter and the maitre d' automatically are happening for you. You don't have to be there. The maitre d' knows all your preferences and can converse with the waiter, who then uses MCP to talk to the kitchen, but you just show up, everything's ready to go. So if we take a review, HTTP APIs, that's like a menu at a restaurant. You've got to order directly from the kitchen. MCP is like having a very good waiter, knows everything about the kitchen and the menu, can answer any questions before you order. And the A to A, or maitre d' in this case, is the agent that just knows everything. It just interfaces where you want dinner, it handles the rest. So that's a fun restaurant analogy. Let's just keep going with that, and let's talk about MCP transports. So how does MCP get that data from your client to the MCP server to make those requests? So we've got 3 different options right now. We have standard IO, SDIO, server-side events, SSE, and streamable, HTTP streamable. So it's about the journey, not the destination. So let's look at STIO. So this is kind of like a bad waiter. There's no order confirmations. They don't know if you got it correct. There's only desktop diners only. It doesn't work with mobile ordering in this case. There's no updates, if you will. If something went wrong, right, you have to completely start over with a brand new order. You don't know when the food's going to come back. It just happens when the waiter shows up the next time. So you make the order, and then eventually something happens. So it stands for standard input output. It's only supported in desktop MCP clients. And that's because the way that standard input output needs a laptop or desktop environment to work. So standard IO is what we support today as of August 6th in our SDK. So only one input, one response. You make the order. You don't know what's going to happen until you get it back. So let's look at SSA. This is the mid waiter, if you will. So you do get that order confirmation before cooking. You do get a little bit now mobile ready ordering world from your restaurant with these SSE enabled waiter server-side events. Something's wrong. You find out in real time, but you can't make any changes to your order. You just know your food's going to be wrong when you get there. And the waiter's going to come back a couple times letting you know the status, like it's cooking, we're almost done, it's happening. You only know from a high level view, your full meal. You don't know about individual dishes. So in this case, this is status updates. So in Claude desktop land, if I'm using an MCP that uses the server-side events, I send my request to the tool, and then I can get back multiple responses for one request. It's only strings, so I only get 50%, 25%, your order is cooking, things like that, not complex data structures, just server-side events sent to my desktop client that I can then populate to my end user, me making order food, to know what's going on with my food order. So we have standard IO, no updates, SSE, very basic string-only updates, and then we have the good waiter. This is going to be streamable. It does everything that we talked about in SSE and more. In this case, really the big difference is that it's going to be complex data. It can be JSON structured so that we can do bigger updates. We can give you an update in exactly how long your potatoes are going to take versus your steak, or how long your rice is cooking compared to your dessert, or when things are going to be ready. We can give that structured data. So still multiple responses to a single request, but now we're able to go through and do much more advanced events from the server, or in this case, streamable. Okay, finally, let's wrap it up and let's talk about some MCP clients. Right now, there's only 2 that I can think of, and that's going to be either web or mobile-based and desktop-based. So really, it comes down to permissions, 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 where desktop is almost kind of like you have your own kitchen in your house, based on the analogy, and the web is kind of like an online ordering or dining room only experience. So let's dive in and look a little bit at the differences between desktop and cloud or web. So desktop clients, these are IDEs like Claude Code, Cursor, VS Code, Claude Desktop, CLIs. It makes sense for system automation and local file access. Like if I want my LLM to be able to open up an app and create a new document, I need a desktop client to do that. And because it is sandboxed in this way, it does make it better for privacy sensitive information where your LLM is only interfacing to your local system if you want it to. And so, as I said, it's kind of like you have a private kitchen at home. You can have bad, mid, or great waiters, and you have direct access to all the equipment. So by that, you can use standard I/O, you can use SSE, you can use streamable. Everything's available for you from a desktop client. Now, from a web client, this is going to be great for like shared team tools, cloud-based services like Copilot Studio, and there's no installation required here. This is going over the web. And so in this case, it's kind of like ordering from an online restaurant chain. Like you can't really see access to all the equipment, what's going on. You have to trust your interface, streamable or SSE. And in this case, it's only available for mid or great waiters. You cannot do STIO when you're using a web client. You must have either SSE or streamable in order to support web clients. Okay, so let's just do a real quick review to put this together for us. So break it down. We've got HTTP, MCP, and A to A. HTTP API, you're manually reading that menu, ordering directly from the kitchen. MCP, you've got a waiter helping you out that can answer questions about the menu, make sure that you order correctly. And the A2A is the maitre d'. You show up and say you want food. Maybe you don't even have to say you want food. You just show up and they know you have food. Essentially, each layer is adding more automation and intelligence, and we're getting from fully manual sending post requests, postman, Swagger docs, to fully automated where agents are solving problems for us. We look at transport methods. Right now, we have STDIO, standard IO, only for your desktop clients. It's silent until food arrives, essentially. You have SSE server-side events. This is available in web at desktop. One-way simple kitchen status updates. Cooking in progress. And you've got streamable. This is going to be web and desktop. This is rich, complex data can come back from the server. More information. You can get richer dashboards if you're building a web client. Keeping in mind, desktop clients can use any of these. Web clients are limited to SSE and streamable. And then let's break it down one more time, desktop versus web clients. Desktop, you have your own kitchen at home. You've got VIP access to the full kitchen. You can do anything you want there. Web, only the front of house dining room. You can still make the same requests, but your level of insight is going to be reduced because you don't have access to the STDIO, the standard IO. You're only over HTTP in this case. The desktop is going to spawn and control that MCP server. So typically that is going to be the npx install when you see in those MCP server JSONs, while in this case, a web client is going to connect to that already running server. So that's going to be the difference between our side is the STDIO or the desktop clients that are leveraging that. They're going to need some sort of middleware to connect versus the web typically connects directly. And then in this case, we do have security boundaries around the web clients to keep them sandboxed so that they don't end up doing anything crazy in other contexts. And that's all I have for you today. Just a quick summary of MCP, a little bit of history, and putting it all together with some fun dog restaurant cartoons. Cheers, and I hope this was helpful.